Good morning, students. Yesterday, we derived an expression for electric field due to plane sheet of charge. Plane sheet, infinite plane sheet of charge, right? Which is non-conducting. See, if this is the plane sheet of charge you have, charge let given is positive charge, and the charge spread on, see, it is a non-conducting. So on both sides the charge appears because it is very thin. Due to this plane sheet of charge at a perpendicular distance from the surface, at any distance, at any perpendicular distance from the surface, such that that distance much less than dimensions or size of sheet. Size of sheet. At this point, if you are asked what is electric field due to this sheet, either here or here, what is electric field? We derive sigma by 2 epsilon naught, right? Where sigma is surface charge density of this thin sheet, right? If you take here, 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 even if you go this side, same it is. So it clearly tells us E is independent of this distance. It depends upon charge density on this plate. And even if you see the direction, if this is a positive charge, direction is outward. You can write like this. Yesterday I told you an example also. R cap. If positive, if this sigma is positive, means if you have positive charge, E outward. If sigma is negative, E inward, right? E inward. These are the basics yesterday we discussed. Now, if you are given multiple plates, more than one, what is the net field due to the combination of plates, right? Like this. This is one plate. This is another plate. There are two plates, right? Plate 1, plate 2. And on this plate, there is some charge. On this plate also, let some positive charge given to those plates. And surface charge density of this plate, for the first plate, surface charge density, sigma 1. For the second plate, surface charge density, sigma 2. This is given situation. Two plates, thin plates or thin sheets, which are non-conducting, they kept parallel. parallel separated by certain distance, right? As shown in figure. Charge density on this plate is sigma 1. Charge density on this plate is sigma 2. The question asked is, if you take 3 points, this is point 1, let this is point 2, and this is point 3. At these 3 points, what is the net electric field? What is the net electric field? This is the question. See, whenever you want to find electric field at any point, 2 things you have to do. You have to see. First, on the plate, what is the charge? Charge density or charge, whether it is positive or negative. One thing. Second thing, assign the direction based on that to the electric field at that particular point. Then take the vector sum of the fields. This is the way to do, right? Then see here. If you see these 2 plates, on this plate, charge density positive. On this plate, surface charge density positive, because positive charges they have. If you come to this point, due to this plate, if I ask electric field, in what direction it is? Always outward, right? Positive, so this is outward. So if I take this is first plate, due to this, what is the electric field here? This is the electric field. Okay. Due to this second plate, what is the electric field at this point? Even it also has positive charge, electric field is outward from it. So due to second even, what is the direction of the electric field? It is also in this direction. E2. Finish. Both are in the same direction. You know the formula, electric field due to the plate, sigma by 2 epsilon naught. As these 2 are parallel, what you can write? At point 1, net electric field, E net. How these 2 are? E1 and E2. Parallel in the same direction. E1 plus E2, right? Then what is the answer? Due to this plate, sigma 1 by 2 epsilon naught. Due to the second plate, sigma 2 by 2 epsilon naught. Then 1 by 2 epsilon naught sigma 1 plus sigma 2, like that, right? Now, what is the field at this point 2? Net field. What is the net field at this point 3? If you are asked, just see here. Due to this plate, at this point, field is outward. So, how the field is? Field in this direction. Due to this plate, outward from that, as it is positive, outward from that. So, E2 is in this direction. Right? In the same way, see here. Here, if I ask, what is the field due to this plate at this point? Positive, outward. This is the field direction. Due to this, it is also positive, outward. E2. So E1 is also in this direction. E2 is also in the same direction, right? Now, if you are asked what is the net field, you can simply write it. Come on, we try to write. Now, at point 2, see what is E net? E net. See there from the diagram how those E1 and E2 are. They are opposite. They are opposite to each other. Parallel, opposite to each other. So that is E1 difference of E2. I don't know which is greater. That depends upon those sigma values. Okay. E1 difference of E2. Then what is common in both? 1 by 2 epsilon naught common. E1 difference of E2. Sigma 1 minus sigma 2. Right. In the same way, at point 3, see there at point 3, how the electric fields are due to this outward, due to this one also outward. So see here E1 and E2 are parallel in the same direction. So they simply add up. So at point 3, what is E net if you are asked? E1 plus E2. 1 by 2 epsilon naught sigma 1 plus sigma 2, like this. Okay. Sometimes in the entrance they ask with 3 plates, 4 plates, 3 plates. Generally, we got the question with 3 plates with direction. So that depends upon 2 things. What are the charges present? Whether they are positive or negative. Second thing, magnitudes of sigmas. Right? So, come on, note down. In this special case, if I give, if special case in this, if sigma 1 is equal to sigma 2 is equal to sigma, means what? Charge density on the first plate, charge density on the second plate, both are given equal. Then from these expressions, can you tell what is E net at the first point, at the second point, and at the third point? At point 1, what is E net? At point 2, what is E net? At point 3, what is E net? See there at point 1, it is 1 by 2 epsilon naught sigma 1 plus sigma 2. If sigmas are same, then what happens? 1 by 2 epsilon naught into 2 sigma by epsilon naught, right? At point 2, here, this is difference. 1 by 2 epsilon naught sigma minus sigma 0. At point 3, again 1 by 2 epsilon naught, it is sum 2 sigma by epsilon naught, like this. Come on, note down. 0.1, 0.2, 0.3. Well, note down or take the screenshot. Next, a small modification on this. A small modification. If one plate is given positive charge, another plate is given negative charge, what happens? One plate is given positive charge, another plate is given negative charge, then what is the net field at these points? Next thing, right? Come on. Let us, positive charge is given to this plate 1, negative charge is given to this plate 2, assume to this plate. Now what is my assumption? Positive charge is given to this plate and negative charge is given to this plate. Negative charge is given to this plate. Right? Whose charge density sigma 2? Here charge density sigma 1. This is positive, this is negative. Come on. Now, what are the net electric fields at this point, and this point? Question is same. What changes whenever charge magnitude change? Only the direction of the electric field changes. Whenever direction of the field changes, as net field is a vector sum, result changes. Yes or no? Let us see the directions of the fields due to the two plates at 3 points. Here, due to this first plate, what is the direction? Positive, outward. Right? Due to the same plate, here at this point, positive, outward. Due to this plate, at this point, outward. So first plate work is over. Come to the second plate. Second plate, this plate. What is this? Negative. Negative. Whenever plate is negative, at any point due to it, field is towards that plate. Towards that plate. Positive, away. Negative, towards that plate. So how the field is? E2 at this point towards that plate means like this. This is E2. I hope you understand this. Here is negative field due to that towards that plate E2. At this point towards that plate, E2. At this point, it is negative towards it, towards that plate. This is the case. So observe the change from the previous case to this case. Here they are in the same direction in the previous case because both are positive outward. Here they are in the same direction because both are positive outward. Here they are opposite in the previous case. In this case, see here, they are opposite here, they are opposite here, they are in the same direction here. Right? Come on, come to unit. At point E1, at point 1, how these two are opposite? So how can I write this? Difference of difference. Clear? Come to this point too. How they are in the same direction. They are in the same direction. Whenever they are in the same direction, they add up. They add up. Come to the point 3 again. They are in opposite direction. Difference. Special case, when sigma 1 is equal to sigma 2 is equal to sigma, magnitudes are same, directions different. In this case, what happens to this? Here, at point 1, difference. Whenever these two are same, difference comes as 1 by 2 epsilon naught sigma minus sigma, 0. Wherever opposite, 0. In the same direction, add up. At point 2, they are adding up. So 1 by 2 epsilon naught sigma plus sigma, they are adding up. Sigma by epsilon naught. At third point also, they are opposite. Opposite in the sense 0. Right? Same thing repeats. Whatever in one, same as. So answer is 0 because they are opposite. Okay. This is the way to do. Number of times problems repeated on this. They ask, the plates are kept in XY plane, 1, 2, 3 plates. At a particular point, what is the direction of the field? Is it towards positive y-axis or negative y-axis? At particular points they ask. Come on, note down. Next, Till now, we discussed electric field due to plain sheet, non-conducting, thin sheet, non-conducting. Now we are going to discuss conducting sheet, conducting plates or conducting sheets. See, conducting plane sheet. Sometimes in the problem they give conducting plates, conducting plates, metal plates, metal conducting one. A metal plate is given a charge something. What is the field due to it? Wherever you find the word metal, immediately idea should come. It is a conducting one. Okay, a conducting sheet, metal plate, metal slab, thin slab. This type of words you get that refers to conducting sheet. Okay. Due to this conducting sheet, at a point, what is the electric field? Right. Okay. There is one conducting sheet. See, consider this is little bit thin, having length and breadth. It is considered as a thick sheet. Let it is a metal sheet. A metal sheet. You are given charge to this conducting sheet. We know already whenever we give charge to a conducting body, where that charge resides, that charge resides on the surfaces. That charge resides on the surfaces. Inside the body, there is no field. See, here there is an inner region, a small inner region. Between this surface and this surface, there is a, as it has little bit thicker, inner region is there. In this inner region, there is no charge. So whatever the charge is given on that, it resides on this surface and on this surface. But in case of non-conducting, it is not like so. Whenever charge is given, that charge spread throughout the body. Already in case of spheres, cylinders, we studied, right? Well, so that is the basic point that we had to remember. To any conducting body, if charge is given, that charge completely distributes on the surface. Inside the body, there is no charge. If no charge, no field. Whatever may be the body, whether it is a plate, it is a cube, it is a sphere, it is a cylinder, whatever it may be, if it is given as conducting, inside no charge present, inside no field present, field is zero, right? Okay. Then we go on. See, generally we are showing plates like this. Whenever I give a charge to this plate, the charge resides on the surface. See, from side, when I keep it like this, and if I see this charge appears to you, and backside also on the surface, there is a charge. But inside, there is no charge, right? So this is a conducting one. Note is what? For conducting sheets, charge distributes on surfaces. Inside, no charge. Inside, there is no charge. Remember this, it is a note point, not only for the sheet, for anything. For my convenience, I am showing this thick sheet like this, side view. Side view. Side view in the sense, generally if sheet is like this is the view. Recording board. See, this is appear to you. This side won't appear. But if I kept like this is the cross-sectional view or side view. So this side charge and this side charge is present. Whenever I give the charge to the body, that charge spread on the surfaces. Spread on the surface like this. This surface and this surface, there is spreading of charge on the surface. Inside here, inner region, in this inner region, no charge. See, in this there is no charge. If it is non-conducting, we draw the charge inside, but it is conducting charges on the surface. Inside there is no charge. That is first thing to understand. Second, the question asked is what? Due to this thick conducting sheet, what is the field at this point? 1. What is the field at this point? 2. Inner point. What is the field at this point? 3. These are the questions asked you. Right? So how to solve, sir? A simple technique, a simple shortcut. If you observe this, it appears that this is one positive plate, this is another positive plate. They are separated by some distance. Right? This is one positive plate, this is another positive plate, separated by a small distance. Right? See, I am considering like this. A thick conducting plate is similar to the combination of two non-conducting plates, conducting sheets, to parallel non-conducting sheets separated by small distance. Separated by a small distance. How small distance? In the sense thickness distance. See, what my assumption is, now this is similar to, can I draw like this? This is one plate. I am showing cross-sectional. See, this is one plate like this. This is another plate. See, distance here I am showing little bit more, but this is the distance. Is it not like this? This is one plate of this positive charge. This is another plate. Another plate. Right? It is just like combination of two non-conducting plates separated by a small distance. That's all. If its thickness is T, that's it. Surface charge density is given. If its surface charge density of each surface, if sigma is the surface charge density, on each surface, then what is the electric field at this point, at this point, at this point? Already for positive plates separated by certain distance, what is the field here, here and here we saw, right? So this is the point 1, this is the point 2, and this is the point 3. Already you know. At this, now here the case is whatever surface charge density here, here also the surface charge density same. So now for this surface charge density is sigma, for this also surface charge density is sigma, because they are the part of same plate. For our convenience we are showing like this. Just I told you, a thick conducting plate is a combination of two non-conducting sheets separated by the thickness distance, right? So charge density on the both the plates same. Special case we discussed, same charge density, same charge magnitude of charge, separated by the small distance, outer E1 in this direction, E2 also in this direction. Here E1 in this direction, E2 due to this in this direction. Here due to this E1 due to this E2, right? Already we solved this. See those answers what you got. Whenever charge densities are same, plates are separated by some distance. E1, what you got? E1. See there, even you can see here E1 plus E2 it is. E1 plus E2. That is E1 plus E2. So sigma by 2 epsilon naught plus sigma by 2 epsilon naught. So sigma by epsilon naught. So here it is E1 plus E2. Here is also it is E1 plus E2. So can I write like this? At points outside. At points outside. See, at points outside, this point and this point, net field is E1 plus E2. Here also net field is E1 plus E2. So at point outside, sigma by epsilon naught. Inside. At point inside, a point inside, come on, E is equal to difference, right? E1 minus E2. So sigma by epsilon naught, sorry, 2 epsilon naught, sigma by 2 epsilon naught, that is 0. So for a thick conducting sheet, outside points, field is what? Sigma by epsilon naught. Inside the sheet, field is what? 0. E in 0. That's it. Right? So whenever you are given problem, whenever you are reading the problem, see there what sheet they asked, conducting sheet or non-conducting sheet. Non-conducting sheet, due to non-conducting sheet, field is sigma by 2 epsilon naught. Due to conducting sheet, sigma by epsilon naught. Just remember these. You can solve any problem clearly just by assigning the proper direction whenever they ask net field. Okay, thank you.